Scientific notation. The scientific notation is a notation that mathematicians and scientists use to write out very, very small numbers and very, very big numbers, or very, very small quantities and very, very big quantities. There are some rules when you are writing a number in scientific notation. Let's start with the number 0.00127. And let's say you were told to write this number in scientific notation. The first rule is to find your first non-zero digit, which in this case is the number 1, and you write that one down. To the right of your first non-zero digit, you put a decimal. And anything that is not a zero, you can write that as well. So I'm left with 1.27. To the right of that, you put a multiplication symbol and the number 10. And then from there, you have to decide what exponent are you going to put to the 10. So what are you going to put here? And so I'm going to show you the trick for that. So what you do is you look at the second number. So as you see here, I've drawn a little eye, and this eye is looking at the second number I've written here, the 1.27 times 10 to the question mark. And what you're going to do is you're going to ask yourself as you are looking at this number, how many times do I have to move the decimal in this particular number to make this particular number look like the number above it? And when I look at the number above, I see I have to move the decimal 3 places. So I'm going to put an exponent of 3. I'm going to keep looking at the second number here and also ask myself, do I have to move this decimal to the left or to the right to make this number right here look like the one above it? And I see that I have to move the decimal to the left, and so I put a negative sign out in front of my exponent. So this is the number 0.00127 in scientific notation is 1.27 times 10 to the negative 3. Now, this number is also written in 3 significant figures. What if I wanted to write it in 4 significant figures? All I need to do here is keep the number as it is, but add a 0. The times 10 to the negative 3 stays the same, and now this is in 4 significant figures. What if I wanted this particular number in 2 significant figures? Then I would round, and I get 1.3 times 10 to the minus 3. And lastly, I wanted to write another option here. What if I, instead of having the number written in scientific notation, I had it written like this, say 12.7 times 10 to the minus 4. This number, 12.7 times 10 to the minus 4, is equal to the number that we started with, the 0.00127, but it is not in scientific notation. And the reason why it is not in scientific notation is because the decimal is in the wrong place. The decimal should be after the first non-zero digit. So because this number, the decimal is not in the correct place, we say that this number is a power of 10 notation. So it's still a notation, a power of 10 notation. It's just not scientific notation. Okay, let's do another example. So let's do number 523,000. And let's write that in scientific notation. So the first thing I'm going to do is find my first non-zero digit, looking from left to right, and that's a 5. To the right of that 5, I'm going to put a decimal, and then any non-zero digits that follow, I'm going to write those. I'm going to write a times, and I'm going to write a 10. And now I need to figure out what is my exponent that I put on that 10. So I'm going to look here at my 5.23 value, and I'm going to ask myself, how many times do I have to move this decimal to make this number right here look like the one above it? And it looks like I'm going to need to move the decimal 5 times. Now, will I need to move the decimal to the right 5 times or to the left? And I will have to move it to the right 5 times to make this number look like the one above it. So it's to the exponent of plus 5. And this answer is in 3 significant figures. Okay, now let's do an example with converting. Let's say I wanted to know how many atoms of hydrogen do you have if you have 11 moles of hydrogen? Well, first thing I'm going to do is write what I'm given, which is 11 moles of hydrogen. I'm going to put that over 1. I'm going to put a conversion factor to the right. And I know that for every 1 mole of anything, that's equivalent to Avogadro's number, or 6.02 times 10 to the 23rd. So Avogadro's number is written in scientific notation, usually rounded to 3 significant figures. So in multiplying, actually let's cancel the moles here. And this unit, by the way, I didn't write it. This would be the number of atoms. In solving this, or multiplying across, I'm going to get the answer of 6.622 times 10 to the 24 atoms. Now this answer, and that's of course atoms of hydrogen, this answer is written in scientific notation to 4 significant figures. If we wanted to round to 2 significant figures, that would be 6.6 times 10 to the 24 atoms of hydrogen. Now, there are some tricks when you are multiplying with your calculator and you have numbers with significant figures. So I wanted to show you, scroll up here just a bit, and show you how I did this on my calculator. Now, depending on what type of calculator you have will depend on what key you are looking for. If you have the Texas Instruments, or more specifically maybe the graphing calculator, doesn't have to be though, but if you have any TI graphing calculator, then the key that you are looking for looks like this. It's a capital E, capital E. It's either, if you have like a regular scientific Texas Instrument calculator, you probably have a key that looks like this. If it's a graphing calculator, then you probably have EE as a second function. So you want to look for it there. This is the key that we're looking for when we're multiplying with scientific notation. If you have a Casio, then you're going to be looking. Again, if you have a Casio, you are going to be looking for a key that is capital E, capital X, capital P. Or some of them are coming out now with a key that looks like this, times 10 to the n. And a lot of times those are down by the decimal on your calculator pad. So you need to find that key. Once you find that key, then I'll show you how I did this calculation. I started by typing in the number 11 on my calculator, pushed the times or multiplication key, punched in 6 and then 0.02. Then I used my EE key. This EE key takes the place of your times 10 when you are using scientific notation. Then I typed in 23, then my equal sign, and then I got my answer came out in scientific notation. Now your answers will not always come out in scientific notation unless you set up your calculator to do so, which it will do. So if you have, again, the graphing calculator, you can just go to Mode, choose Scientific, and you can also choose your calculator to round your answers to 3 significant figures if you like that as well. And from that one you choose, so first I'm going to choose is Mode, look for Mode on your calculator. Then you can choose that you want it in the scientific mode. And then you can also look for flow. Most of the graphing calculators have an option of flow. Some that are just scientific calculators might say fix, and then you're going to choose what number. Fix means how many numbers to the right of the decimal do you want, so you're going to choose 2. Flow means, typically it means how many significant figures do you want, so you may choose 3. And that's if we're going to try and just stick with having our answers rounded to about 3 significant figures in this class. Anyway, you want to make sure that you come and see me if you have any questions on working your calculator. I'm more than happy to help you with that. Here's your practice, and these problems will be due the next time I see you. Good luck and have fun.